Hey there everyone, all the techies and data enthusiasts there. Welcome back to my YouTube channel. So guys, from today we are going to start a new series or a playlist called Unleash the Power of Different Types of RAG. So in this particular playlist, we will be covering each and every type of RAG. So there are more than 25 types of RAG. You will be expecting or you will be getting all this rags detailed explanation in a form of videos. So this playlist will be continuous. When you get the new type of rags into the market, I'll create videos on them as well. For now, these 25 types of rags will be covered, where on each video I'll explain what is that particular rag. It can be standard rag, graph rag, adaptive rag, self-corrective rag, or a correctiveness rag. There are multiple types of rags out there. So we will be discussing each and everything one by one. I'll be explaining you about what is that rag and how it's work and its architecture flow, then a practical implementation on it as well. So it's gonna be a very interesting series, guys. I hope you all like, share and subscribe the channel. And in today's video we will be covering about introduction to RAG. So what is RAG exactly? And there are two methodologies how using which you can work with RAG. That is nothing but prompt tuning and fine tuning. And before that, what is an LLM? So we will be discussing about all these topics in this particular video. Then from next video onwards, you will see each and every RAG one by one. So I hope you all will like this particular playlist. Make sure you all like this video, subscribe the channel and share this video on LinkedIn and tag me. I'll definitely react to your posts. So guys, now let's get started. So guys, before we dive further into RAG, it's very important to know what exactly is an LLM. So think LLM as a base or a building block. You should definitely have a strong foundation and know what exactly is a LLM, which is nothing but large language model. Do you all know, a question guys, quick question. So do you all know what is the base or the base model of LLM, because of which you can say that these all the latest LLM models are being created or the AI is in boom? So there was a paper released on 2017 by Google. So that particular paper name, I want you all to comment below. So that particular paper and the architecture released on that particular paper is a game changer, because of which now the AI is in boom. All the latest AI technologies you are seeing and these LLM models, everything are created based on that particular model only. It is a base. Without that particular model, you might have not, we might have not have this LLM models itself. So guys, I want you all to comment below. Let us see how many of them will comment what is that particular model. You can either comment the paper name or the model name directly. So guys, now let's move further. What are LLMs? LLMs are nothing but a large language models that are advanced AI systems designed to understand the human language or a human generated language. They are trained on vast amount of data, billions and billions of parameters. These models are trained on that billions of parameters of text data, whether it can be mostly trained on Wikipedia dataset, book datasets, and even some of you can say blogs which are publicly available. Mostly these LLM models are trained on publicly available data ethically, so instead of giving the personal data of a company. So if you sometimes see that the model is hallucinating, it is not because the model doesn't understand your question or it is it is not performing well. The main reason of the hallucination of model is because all these LLM models are mostly trained on books, PDFs and Wikipedia datasets and some of the publicly available datasets. In all these datasets, you cannot expect to have a profit and loss of a company, a balance sheet, and all these kind of high level works which are done in a company. Mostly the code bases, obviously the code bases are used to train. So this GitHub is there, so they extract the code or publicly available repos and everything, code from those repos, and they train a code based models. So you will observe that whenever you ask a question related to code, the model will try to generate properly. At least the boilerplate code will be correct. But when it comes to the other questions, if you ask, if the model doesn't see or it's an unseen data, then definitely you will see the hallucination in model, or it is trying to create something or make up some answer instead of saying it doesn't know. This is one of the biggest drawbacks. So always when the model gives directly, don't try to directly copy that and use that. LLM models are not 100% correct, so even they might dream. If they dream, then the nightmare happens. Okay, so real world example, consider a virtual assistant like Google Assistant, where you ask about the directions, weathers and everything, how this particular like for example, take an example of your Google Maps. How will it get to know that you should go left, right to this particular location? Based on the data it is having, right? So the publicly available satellite data and continuous tracking, based on that only the model can tell you, okay, take the next left, right, or else go forward, all these things. So it internally uses the LLM. This particular voice assistant also, Google Assistant also uses LLM to search and give you answers out. Why use LLM? LLMs are valuable tools of several reasons. For several reasons, one is efficiency. They can process and analyze large amount of data quickly and provide the answers in seconds. Versatility. LLMs can perform on wide range of tasks beyond simple question answering, including summarization, translation, and content creation. So example, you can make an LLM as a content creator or an image generator. So you can see here, this particular image was generated using DALL-E 3. I'm openly telling, I guess you all might have guessed by seeing these questions. I mean this text actually, it is not that clear, right? But you can see we can use it for image generation. Compared to DALL-E 3, ideogram will generate more realistic images. Okay, and it can be used in different use cases. Personalization, you can fine tune the LLM and you can use it for your specific task. Personalize specific task, example an healthcare bot, so you can have a specific LLM assistant for an healthcare itself, or else you can have an LLM assistant specifically for you can say real estate industry. So it can be anything. The LLM can work on all this particular specific tasks as well. Training LLM on specific domain or data set, there are mainly two ways to train or two ways to make the LLM models to adapt to a particular task. One is either fine tuning or prompt tuning. What is fine tuning? Fine tuning involves take a pre-trained model and train it further on a specific data set, whether it can be a real world example like generating you can say generating a recipes based on the cooking data it has or the information fine tuned. So here you have an image. Let me explain you in more detail with an example. First, suppose fine tuning an LLM model. So to fine tune a model, first you should have a pre-trained LLM model, whether it can be Meta, LLaMA model. Yes, okay, just give me a second. Whether it can be a LLaMA model or Mixtral. So any LLM models, whether it can be any of this particular model, it can you can use any of this pre-trained model. So now you have a pre-trained model. Next task to train this model on a specific domain data set. Whether this can be a data set on recipes like 10,000 recipes, 10,000 recipes, or it can be a custom agent, or you can say custom agent you can build on queries asked on real estate. So real estate agent, real estate data. So it can be anything. So you can give this particular specific domain specific data to an LLM model and train it. So when you train or fine tune it, it becomes a trained model. So this particular model now is having, it has seen your entire data. It can understand the 10,000 recipes. It has, you have fine tuned it in such a way that it can create its own recipe based on this 10,000 recipes. Now you can start to test this model. You can test this model, evaluate the performance. You can ask question to generate biryani recipe, so it can generate a biryani recipe. You can ask it to generate a recipe on sushi, so it can generate a recipe on sushi as well. Any questions you ask, it can do it. So if you want, you can ask it to generate not only a chicken biryani, you can ask it to generate a fish biryani recipe, mutton biryani recipe. So whatever biryani you want, it can actually generate based on the understanding the model has. Evaluate the performance. If the model's performance is perfect, then it is ready to be deployed to production. If it's not performance, again follow the same task, adds some more 10,000 plus data, and it will be 20,000 data, and again fine tune the model, check the model performance. Then once it is perfect, you can deploy it. Okay, so I hope you all got this. This is how normally fine tuning in large language model works. Just give, you have a pre-trained model, add your specific domain data and train the model. That model becomes a trained model. Then you, once the model is ready, you can start testing it and evaluate its performance. This is a simple fine tuning process, how it goes. Okay, you don't need to understand what is LoRa, QLoRa, all these kind of specific fine tuning techniques for now. When we go forward with the fine tuning it specifically, then we will read about it. Okay, so this is all about fine tuning. Next we have prompt tuning. Prompt tuning involves designing specific prompt that guides the model's performance without changing its underlying weights. Real world example, think of a teacher providing tailored question or scenario to help students focus on specific topics during review sessions. The teacher knows what the students have learned but gives them targeted prompt to enhance the understanding on particular areas. Simply I'll tell you an example here. So this example here, what simply we are trying to tell is, teacher already knows how much she or he taught syllabus to you all in a class. So when they are going to ask question, they are mostly going to ask question based on those particular syllabus which they have taught. They are not going to go out, and sometimes they might go to general knowledge questions and they might ask you to test your knowledge. The same way, how the students are adapted to what the teachers what teacher is teaching, you can actually write a prompt and make the model to adapt to a specific task itself without fine tuning. Just give a prompt, given as an instruction. So the instruction what you are going to give, based on that the model can actually act or mimic like being in that particular field itself. For example, act like a SEO expert. If you tell to ChatGPT, act like an SEO expert to me and give a trending keywords using which my video can go viral on YouTube. So it will definitely search and give you the trending keywords based on the topic you give. How it is doing? Based on the SEO optimized keywords, it extracts, because it is acting as your SEO optimized expert that particular chat in that particular chat session. Same way goes here, how we are going to give the prompt to the model and how we are going to tune the model performs in the same way. So let me easily explain you this one as well. So prompt tuning is very easy compared to fine tuning, and moreover in fine tuning you require lots and lots of resources, but in prompt tuning, if you have an idea about the model and how to work and whether if it works definitely, then you can actually see. For suppose here you take, in prompt tuning what it happens, task one is to identify the task, whether it can be a specific task like you can say real estate real estate, or act as SEO expert. That's all. So based on this SEO expert, it should act. Then you have to write a prompt based on this. When you write a prompt, then the model, what it is there, right, the effective prompt, when you write to it, the model will become a kind of condition based model, which is specifically given a command to only act as a SEO expert, do not extract any other answer. So this is now your prompt tuning model after giving a particular task and its prompt to the model and adapting it. Finally, you have to once the model is adapted based on your task, then you can test the model. Test, and if there is any error, if it is not giving the proper response, change the prompt. You have to iteratively change the prompt multiple times, and where it is to making error, then again you have to change the prompt again, retry. This is an iterative process which can go for multiple times. The more perfect you give the prompt, the more perfect you get the results. So that is exactly what is called prompt tuning. Workflow of an LLM model. Workflow of an LLM model. So before we go forward, so let me see here. Why fine tuning is better than prompt tuning? Obviously, prompt tuning is good, but fine tuning is more better because let me tell you, customization. Fine tuning allows deeper integration and domain specific knowledge compared to prompt tuning. Here I'll tell you with an example. In fine tuning, what happens when you are giving model a data, then the model is understanding your data, it is learning your patterns. So based on those patterns, the model becomes a customized fine-tuned model. When you ask question, it already knows what from where you are asking to that particular model, and based on data it can understand and it can answer you. But when it comes to prompt tuning, so if you ask in prompt tuning that act as Lord Rama, it's just an example, act as Lord Rama and write, or else you can say act as Veda Vyasa and tell it to write the complete book. Then will it write complete book of tell to write complete book of Mahabharata? So will it write the complete book of Mahabharata? Obviously, if the model has the data internally of Mahabharata, might be it can write, or else it will try to make up something, it will try to dream itself and it will try to create an imaginary story. It will not 100% write the same what is there in Mahabharata book. Okay, so if you fine tune the particular model with Mahabharata book, then obviously when you ask questions related to Mahabharata, then the data that chatbot can easily answer questions because it is specifically fine-tuned on that particular data set. If you ask the prompt-tuned model which doesn't know what is Mahabharata actually, if you ask questions, then it will definitely answer you illogically. Okay, that is why we say fine-tuning is better than prompt tuning. But sometimes we have to follow the hybrid approach. We have to even fine-tune the model, parallelly do prompt tuning to get perfect results for production. How LLMs work: input, text pre-processing, context understanding, prediction generation, and output. So let me explain here that one as well. So you give an input data set or any input question, so whatever input you give, it starts to pre-process, text pre-process. It removes full stops, question marks, exclamatory marks, all the special symbols, spaces, braces, all these symbols, hyphens, and it creates a kind of pre-processed data tokenizing. If you have started to learn NLP, or if you already know NLP, they all know what is tokenization and text pre-processing. Lemmatization and stemming takes place there. So all this process internally happens here. Then contextual understanding. So whatever data you have provided, based on that it understands the context. understand context or meaning. What is it? Then based on that it prediction generation. So based on the question you have asked, or based on the data you have provided, if you ask the question, it generates the answer. Based on understanding, and finally you get an output. So this is what it normally happens here. I hope you all got this. So this is normally the workflow of an LLM model. So that is only here. Then when do you use LLM in writing assistant applications? And right now exactly in every AI use cases we mostly use a large language model or a SLM. We say SLM, small language models. Even we use that as well. So understanding cost involved. So knowing LLM is not a great thing. Even you should know the cost involved in it. Adapting LLM to fine tuning can be resource intensive. It can be a very costly model, or you can say it can be a very costly factor. The more data set you have, if you want to fine tune a model, you require GPU, computation, server space, and specific time for it. And if there is any errors, if you are hiring someone, so all this cost effectiveness comes into fine tuning. When it comes to prompt tuning, you can give prompts and get specific task out, but it cannot be 100% accurate. Not only a fine tuned model or prompt tuned model, any LLM model which is outside, it is not 100% accurate. Even if the companies claim they are 100% or 94-95% accurate, also it is not. Because if there is any unseen data, and if you ask an unseen data questions based on this unseen data, it will definitely try to make up the answer or generate a answer in its dream imagination. Even LLM models can dream. They do daydreaming, night dreaming, 24 hours dreaming actually. Okay. So it depends, you have to manually evaluate the answer. Without that you cannot specifically come to an assumption that it is given 100% perfect. So fine tuning LLM is resource intensive, so you have to make sure the cost involved you are ready to bear for it. And if you're prompt tuning, you have to better understand the prompt and you can go based on the use case. Now what is RAG? Retrieval-Augmented Generation is a type of framework that combines retrieval system with language generation models. It retrieves relevant information from external sources while generating text, ensuring are not only accurate but also contextually rich. Why we use RAG? RAG enhances traditional model by allowing them to access up-to-date information dynamically. This means when you ask a question, RAG can pull the relevant data from various sources before creating the response. So normally previously what it happens when you have a pre-trained model, if you ask it a question, either it can give you an output or it can dream or imagine and give you an frictional output, or it can also say I don't know. Any of these use cases should be there. But when you connect RAG with this LLM model, and if you give it a data source, whether it can be your own data source which is available in either if you are using Azure in your blob storage, or if you are using some other vector databases like Pinecone, Quadrant, if you are providing that. So when you ask question, so when you ask a question to that particular model, what it will do, it will first fetch from this database which you have linked, or if you want it to fetch from Google, it will fetch results from Google if there is some unseen data, or if it doesn't know what the output should be. Then it will fetch, it will check, if it is perfect, then only it will provide you the answer. Here, getting the accurate answer, you have added another layer called RAG to get a perfect answer. whether it can be searching from Google or whether it can be searching from your own data sources. If it's your own data sources, your task is maximum easy, because whatever questions you ask, you get the outputs immediately. So based, if it is available in that particular data source, it will summarize, it will answer, try to even explain the topic which is in that if you don't understand, using RAG. So RAG can be a more advanced system, or it can be a kind of helping assistant or a next level advanced assistant for an LLM model. If you combine RAG with an LLM model, it's an advanced assistant. Okay. How RAG works: query submission, then document retrieval, response generation, output delivery. Mostly here how RAG internally works is, it gives the output based on similarity, based on your question, how similar it is getting the answers. Based on that, it provides, like similar it is related to the answer. If you have like if you are very new to data science and if you're seeing this for first time, you might have no cosine similarity, which you might have read in your mathematics on your grade 11th, 12th, or might be in 10th as well. Even if in your engineering also, you might, there is a cosine similarity concept, where the closely related data points are in that which is on the topmost priority, that is considered as an answer. So here the same thing happens. Whatever question you give, based on the question, the closely related data points, it figures out answers on the top 1, 2, 3. You can give a top k, how much how many responses you want. If you give 1, you will give only the top first response. If you give 2 responses, 3 responses, you can get accordingly. Obviously this one, when we are going to do practically, we'll understand very clearly. So guys, that's all I wanted to explain you all for today's video. It's been more theoretical, but this is 100% required. If you understand this, going forward in the next concepts, I don't need to waste more time. I can directly jump into practicals. So guys, that's all for today's video. Do like, share and subscribe the channel. Meet you all again in my next video. Bye bye.